Good morning. Welcome to my video on the thermal dynamics of a Stirling engine. I have a little Stirling engine here running on a coffee cup full of water. The coffee cup directly heats the blue plate on the bottom, and that expands the air inside the little chamber in here. And as that air expands, the piston over here expands and pushes the connecting rod up and around. Okay, but we only want to use half of that expansion. If we use all the expansion of the gases, we won't trap any pressure. And without pressure, there's no work done. So we want to only allow it to expand to half its volume so that it keeps at least half its pressure, so that we get the most efficient use out of it. That's what I call direct expansion, where the heat directly on here expands the air in the chamber. Now the next principle I want to discuss is displacement. And displacement is where the foam piston, the displacer piston, goes up and down and moves the gases from the bottom to the top, from the hot side to the cold side. Now when the gases are displaced to the cold side, you have direct contraction up on the cold side, and you got the reverse principle where the contraction pulls down on the piston, pulling the piston around. And just likewise, we only want to use half of the contraction to maintain half of the vacuum to get the maximum power. I call that direct contraction. Now, Stirling engines do something that no other engine can do, and here's where a lot of their efficiency comes from. This foam piston in this one is porous, and the air actually travels through it, not just around it. And as the air goes through it, when it is going from the hot side to the cold side, that cold air is going through the piston and heating up and expanding as it goes through the other side. And conversely, when the piston's going down, the piston's already hot, already cold from just cooling off, going up. And as it goes down, the air passes through it and cools off, and causing contraction. So you have a regenerative expansion and contraction going on because of the heat transfer inside the piston. For this reason, most Stirling engines have either some kind of foam, or most common is actually steel wool, to regenerate this heat as it goes back and forth. That's what adds to the efficiency of a Stirling engine. Every engine has to have a hot and a cold. Even a jet engine has a hot and a cold. In a jet engine, the cold air is drawn in through the front. The gases, it's compressed, the gases burn it, it expands, and has 8 times the volume going out the back as it did coming in the front. And this can turn the turbine easier to run the whole system. Of the heat energy that a jet engine makes, the most modern jet engine to date is only about 12% thermal efficient. Only 12% of the heat turns actually into work. By running a lot higher compression, a gasoline internal combustion engine gets up to 25% thermal efficiency, where 25% of the heat turns into work, 25% of the heat goes out the radiator is waste, and another half of the work goes out the tailpipe is unused heat. But the Stirling engine, just the direct expansion and contraction, is only about 5% efficient, depending upon how much the difference in temperature is. But because of the regenerative nature, Stirling engines have gotten up into the 90% thermal efficient range, which is pretty high. So, this is a little toy. In my previous video, I talked about how this could power your house and do all this great stuff. Well, how do you do that with a little toy? Well, you don't. You supercharge it, upscale it. And the way you supercharge it, one way, is by compressing the air in which it operates. If you operated this in a room with twice the air, it would have twice the power, because the air in the cylinder would expand the same amount but cause twice the pressure. So if you built a air tank, put this thing in an air tank, and boosted the air pressure up to 140 pounds, this little engine would have 10 times the power it does now. The same engine. But we can go 10 times that. We could make this engine 100 times as powerful as it is by incorporating it in a 3,000 pound cylinder. You say, well, if you put it in a cylinder, how do you get anything out of it? How do you get the electricity out? How do you get the power out? Well, if you've ever seen a refrigerator power unit is a little black container. Well, in that little black container is an electric motor and a pump that are sealed inside the unit. The only thing that penetrates the side is the wires. Likewise, you could have a Stirling engine sealed into a high-pressure tank, with the only thing leaving the tank is the wires from a generator that the Stirling engine does. I have a series of formulas done on a spreadsheet that will show the different outputs of the different size Stirling engines as supercharged by some of these methods I've been talking about. And I love when that little thing runs. And I want to share that with people. So click on my site here, and I'll see what I can do about getting you one. Thank you very much.